Given the formula S of n for integers n being greater than 0, we're asked S of n is equal to n plus 1, and this is divided by 2n, and I think this should be 2n squared. It's missing this little symbol right here. We're asked what is the behavior of S of n for large values of n. So we can rewrite this as S of n is equal to n plus 1 divided by 2n squared. So this is going to be our equation. And we can just say that large value would equal to infinity. And so we can set the limit as, let's say, n approaches infinity to be n plus 1 over 2n squared. And then we can plug in infinity for both of these. If we plug in infinity for both, we're going to have infinity over infinity. And so we could use a Laplace rule. I think that's what it's called, or the Laplace transformation. But basically, it's where whenever you have 0 over 0 or infinity over infinity, you can derive the numerator and the denominator. So if we derive the numerator, we're going to have 1 divided by a 4n. Now, if we plug infinity inside of here, we're going to have 1 over 4 times infinity, which is just infinity. And 1 over infinity is 1 over some huge number, which is approximately 0. So what is the behavior of Sn for large values of n? And let's start with a small number as well. So we'll just say S, when we have 1 in here, it's equal to 1 plus 1, which is 2, divided by 2, 1 squared, which is 2, is equal to 1. So we're going from 1, ... all the way to 0. And so this means that our values are getting increasingly small. So every time we add in values, it's going to get smaller and smaller and smaller. And we can show this as well on a graph. So bringing the graphing calculator down here, we can see that we are going to have n plus 1, but I'm just going to say that n is x. So we'll have x plus 1, and we're dividing this by 2n squared. And so let's look at, 2n squared, it should be 2x squared as well, because I'm substituting out the x, or the n for the x. And so we're going to have this as our equation, right? It matches what we have here. So we can see that it starts off right here, and then it slopes downwards, and it goes all the way down here. And it will get smaller and smaller and smaller. We're looking at the y-axis. When we're looking at the second number for when we're looking at how small it's getting. So we can see it's going smaller and smaller, and it will continue getting on smaller for an infinite amount of time. That is how you'd go about doing this problem and doing the graph for this problem.